All right, good morning. After a little bit of late start, you can start because so many of you arriving late for class. I think becoming a very bad habit. I need to stop it. I need to start set a time where you come past that time, you don't enter the classroom and lock the door. Come on, man, we can't start slack off at this time. This is what we're supposed to get locked in and get serious. Another thing, find out a number you're missing out on the mock exams. They don't make any sense. Just come in here on the day when I'm working on the paper. I can't help you. You have to do the paper yourselves. Right? Come and watch me do the paper. That's not good enough. You have to do the paper. So that when I'm going through the paper now, you see the mistakes you made yourself. Anything that was not clear, you get to clarify yourself. Right? Then any question that you got wrong, you are supposed to go and redo that question as many times as you need to do it until you can do it straight by yourself. And that's why I record these sessions, share these sessions, so that you can use those videos to help you through the process. To maximize everything that's available, it helps us get maximum results in the exam. Everybody in the class, they get a 1 with skill. Just at the level of preparation that we do. We have to form a participate fully in the program in order to gain maximum benefit from the program. All the classes, so that assignments and all these things, we're going to show you results. To maximize and do everything that is on offer in the program. You will do results. Those are shut up about. It can't be that you're missing classes. I don't have any reason. Somebody have a class or they're sick or something, well, fine. But even so, you still have to find time to do the paper on your own because on the exam day, remember, it's the matter that you're going to have to do these questions on your own in the exam room. Right? And the more you get comfortable doing these questions on your own, it's easier it will be for you in the exam room. And that's what we want. We want to be that when you go to the exam room, you're in a comfortable state. Confident and you know what you're about. You don't trust the paper. You don't feel anything strange in the exam room. You feel like you're in familiar territory, like you do them already. That is what we are preparing for. If you don't do your part, then you're not going to get the maximum success in this subject. I'm telling you. Not rocket science. What I'm doing here is tried and proven. Proven already. So I'm not trying to do this now. I'm doing this thing. But you have to come and follow along and follow the process. Follow the process 100%. And some of you are missing out too much. Some of you don't come here to do the mock exam yet. At least some persons that can't come on a Saturday, they come here Friday evening and they do the paper. Not the best, but still better than nothing. They come Friday evening and they do the paper. So if you know you can't come Saturday, you have a class, you have something else, whatever, you could take the next best thing that's available. Come and do the paper Friday. Doing it after me now, not good enough. This is the time you do it before me. You do it before me. Before we get to March, when exam prep start, it was okay for you to do it after I do it and explain it. No, it's for you to do it before me. Then when I do it, you see your mistakes, you learn from your mistakes, maybe see another way to do the question, whatever it is. But that is all you benefit by doing the papers before I do it. You also need to practice management of the time. You need to practice the pace at which you need to work. That's why we try to do the mock exams under time restriction, exact time restriction that you have in the exam room. You must know what 10 minutes feels like by practicing. You know what 15 minutes feels like. You know what 20 minutes feels like. Comes with practice. And I'm keeping records of who doing the mock exam, who not doing the mock exams, you know. Because I guarantee you, when the exam results come, I'll be able to align the attendance rate to the mock exams to the grade that people get. People who get the ones with straight A's, you will see that they attend the mock exams. They do them. And they can't come, they do the papers. And the people getting 2s and 3s and 4s, They are the ones who don't come to the market. It's simple. That's how it goes every single year. That's how it goes. So you decide which group you want to be in. It don't make no sense to come to a program like this and don't gain success in this subject, you know. It doesn't make no sense. Not a program like this one. And I know plenty of other programs out there. Know them. Some people still learn stuff now while you are doing mock exams. Some people still learn vectors and transformation and trigs now in other classes. While we in this class finish the syllabus and doing exam prep. Some people learning topics the week before the exam or the day before the exam. They're just learning something. They're not well prepared. This program is set up to prepare you well. Right? Okay, go in the exam and feel comfortable and have fun on the exam day. And sleep full 8 hours the night before the exam. Other people have to study hard night before exam. We don't intend to do that in this program. The night before the exam, you're supposed to go to your bed and just sleep like a baby. Because you know that you're well prepared. And you get up the morning after the exam and you have to look over nothing. You just go straight in the exam room when you wake up. Just as how you wake up on a Saturday morning and just come here straight and look for nothing and just come to the paper. Same thing on exam day. You wake up the morning, you go straight to the exam room, you don't do no maths at all. Because you are so well prepared, you just go straight in the exam room and just do the paper. And come out smiling. And send me a message where it says soft in it. Serious, serious, serious. That is how it goes. But you have to play your part in the program. You have to do everything that I tell you to do. Can't skip out nothing, can't miss out nothing. There's nothing in this program that is arbitrary and random. Everything has a specific reason. You're going to be assessed at some point, and if you don't do these initial papers that I'm setting now, I won't be able to assess you later down to see how well you're progressing. I won't be able to assess you if you don't do the papers that I'm giving you now. How am I going to assess you? What am I assessing again? I have to assess again something to know if we need some intervention, if we need to do something different, if we need to add something to the program, if we need to do something more. When we do the assessment. So if you don't do these papers, for me to see what the progress is and see how well you're progressing, when I do the assessment, there's nothing to gauge the assessment against if you don't do these papers now. And I'm not telling you when I'm going to assess you, I'm just going to come one day and say, okay, this is the assessment. Because it has to be realistic. I can't have you preparing for the assessment. Because I want to know where you're really at. I want to see the assessment is to test how well you are learning from your mistakes, how well you are not repeating mistakes. That's what it's about. How well you are not repeating mistakes. Right? How are you doing what I say that when you do a question and get something wrong on it, you redo the question and eliminate the mistake. Eliminate it. It don't make no sense here. I have a weakness now. I know that you have a weakness in something now. I don't do nothing about it. You have to do something about it. Because I don't know what's coming on the exam paper. So anything we encounter now, we have to clear it as a hurdle. Clear it as a hurdle. Anything that's a problem now, we have to get rid of it. Right? The miss also come to me. She have identified things that you want to go over. That's what it's about. Identifying things that you want to go over. And we could put something in place to go over them. Knowing what you don't know is very, very important. You can't know what you don't know if you don't do this work. Knowing what you don't know is very important. That way you're not progressing, you're not going ahead, going towards the exam blindly. You have to know what you don't know. So we can address it. You come to the time, say, I will send me a message, sir, I want to go over this, I want to go over that. I send me something on this. Because if you know what you don't know, that is how you gain success. Right? Same thing with merchant over there. So. People doing it, people sending me a message and say, sir, I want to go over this, I don't know this, I want clarity on this, that's what you do. You identify the things that you don't know. And you say, sir, I want some help with this, I want to go over that, I want this. You cannot know if you don't do the paper then. And see the things that give you problems. So we can address it before the exam room. Tell you all the time, you know, guys. I am prepared to work as hard as I need to work to help you. But I can't just come and just help you. So you have to come and meet me halfway. As much help as you need, I'm prepared to give that help to you. To help you clear, because what I'm here about is to get you to gain maximum success in this exam. But you have to do your part as well. Once you identify the areas that you have an issue in, you have to let me know so we can do something about it. Right? And based on some of the questions people asking me, I know that, okay, we're going to be able to address those things because I'm going to have some sessions, like some marathon sessions. And we'll full whole day marathon talk because some of them don't really make no sense to me. Right? Some quality sessions where I'm focusing on one topic at a time. I just need to schedule them. We might have a class where we're dealing straight with bearings. And have another class where we're focusing on matrices. Another one on transformation. Another one on vectors. I'm going to schedule them. And those are going to be outside of our regular program. Not in the regular program. Those are going to be outside the regular program. Now, we don't have the time to give up in the regular program. The regular program is already set and scheduled. So these are additional stuff. We have to do them outside of the regular program. So maybe like in the Easter break, we have to do those things. So maybe like back-to-back classes, 4 hours, different from the regular class. So might have a class, for example, on a Sunday. We finish the class 2 o'clock, and I say, okay, guys, I'm going to have a session at 5 o'clock. Same day, we're doing transformation. Out of 4 hours of transformation. Just transformation alone. Another day, just vectors. Based on the questions persons asking that they want to do, we're going to do those sessions. All right? We're going to put in the work, man. You can't joke about the thing, man. You can't joke about the thing. There's going to come a point the pass mark is going to be real. Real. It makes it 70%, 70%. Real. 50%. I don't say 35% is just because we start with giving that progress. But there's going to come a point with the pass mark, I got the real pass mark I will take it. And that time is coming soon, not far away. Coming soon. Man, so the start it goes, man. So if you say 35% of the pass mark, try it 70 from now. So when it's time for 70, it's 90. So when I say it's 90, it's 95. That's how you do it. Man. I have to seriousness from now and go forward. Seriousness. And I have to tell you, I'm people that don't understand. We don't have class 5 days a week now. 5 days a week. We have class Sunday, Monday, Wednesday, Thursday, Saturday. So you in here, face to face today, online tomorrow. If you can't make it to the class, it is recorded. You will find time to go and watch the video. Because we're doing the other paper tomorrow. Because we have to double up the work. When other people out there do 1 and 2 mock exams, we are the 24. When other people out there do 2 and 3 multiple choice, we are the 30. I'm serious. You can't be ordinary. When you're ordinary, you get ordinary grades. You don't want an ordinary grade inside you. You have to be extraordinary. You can't give extraordinary results by doing ordinary things. Man, I'm not a joking man. You can't forget serious now, man. Exam on the man. When I wait for let's do this here. Let's do this here. You know what? You have another mock exam, don't you? And a mock exam Thursday. Yeah, 2 mock exams Saturday. Every weekend is 2 mock exams to have. One that you do here, one that you do. After the repeating it, some people like them don't know. And the mock exam is here, face to face, not at home. Here. They don't stay home deliberately because you feel like you want to stay home. Man. Come here and do it under the conditions of exam. come here and use under the conditions of exam. Don't stay home because you can't stay home. I'll go somewhere else. You're not doing anything, you come here and you do it. You can't come Saturday, come Friday evening for this. And you have one you do at home. Make sure you do it. Make sure you do it. Otherwise, you're not get the best grades one you can get, man. Come on. One with straight A's. Not no good like that. One with straight A's. That is always the case. One with straight A's profile. Come on, you can get that, man. That's what you work towards in this program. Now, settle for not less than that. Now, settle. All right, let's do it. First question here. Let's get through this. Let's get through this paper quickly. That's an easy paper. Someone use a calculator to work that out. Let's say use a calculator to work out a calculator. If we're not using a calculator, we would have basically work out the bracketed term first. And then after we see what that value is, then we divide by this. That's all. But you are blessed to those calculators that you can start to see just as it appears there. 3.6 as a plus square root of 51.34 divided by 3.75. And it's the same thing you have on the calculator here. Same thing, check it and score. That's any one thing different. The answer going to be different. You make sure the same thing you have. Right? That looks like the same thing to me. I'm just going to write equal 2.83. That's like exact value. 2.83. Next part. Better buy question. Remember, for the better buy question, there are two ways to do it. You can say how much you're getting for $1 or how much you're paying for 1 gram. Sometimes how much you're getting for $1 is the easier way to do it. You bring this one down to $1. Do like a ratio. And see how much of this butter you're getting for $1. And you bring this down for $1. See how much butter you're getting for $1. The one that you're getting more of for $1 is the better buy. Let's look at it. This one is the better buy. So this one, it is $2.14 for this amount. I'm going to do it like a ratio. So it's like this amount of money to this amount of grants. I want the money to become 1. So for the money to become $1, I'm going to divide by 2.14. Divide by 2.14. I'm going to divide by 2.14 so that this becomes 1. So I divide by 2.14. The money becomes 1. Divide this by 2.14 as well. So 150 divided by 2.14. That's 70.1 grams. So on this jar, $1 gives us 70.1 grams. On this side now, I want again the money to become $1. Because if it's $6.50 I want to become $1, I'm going to divide this one now by 6.5. So divide this one now by 0.50. So that the money becomes $1. Now this jar, $1 is the money. Divide this now by the same 6.50. 400 divided by 6.50. That is 61.5 grams. I'm getting more for $1 on this jar. This jar is the better buy. Better buy. I'm getting more for my dollar. But understand that. Don't give each of them down to $1. The one that gets more off for your $1 is the better one. It's like that. It's like a ratio. Divide everything on this side by the 2.14 from 1, the money to become 1. So we divide the money by 2.14 and divide the quantity by 2.14. Over here, I want the money to become 1, so I divide it by 6.50. If we divide this by 6.50, I put the dollar sign for this should be gram. Should have been 61 pounds. So I'm getting more for my $1 over here. So that one is the better one. And that's my justification. And I can leave this as my calculation up here. See, my calculation is going to be so. Okay, show all working. So that's my work. Divide that by that, divide it by this. You will accept that. I'm going to tell them now that this 150 gram jar is the better one. There's no fair. This is something I would do in the real world now. Right? More for $1. Sometimes I would do this in a real world. Sometimes you go so much to have 2 different types of them. I just get a calculation in. And pick the side, this one, that. And I do it all the time. Going down with my phone and I calculate. I want to buy the big thing or the small thing. I want to see which one I get more. Most times the bigger one is the better. Most times. And it's more. The bigger jar is the better. Most times. Per unit price. We get to one. Right? Anyway, let's continue. This one says, how much invest this amount of money? A 6 year at 6% simple interest per annum. Calculate the interest in dollars earned after 6 months. The 6 months here very important. Let's talk about this a little bit. Remember, the formula for simple interest is that I equals PRT divided by 100. Everybody must know that formula. Simple interest. P is the principal amount. R is the rate percent. Rate as a percentage. That's why the 100 is here. For example, like how the rate is 6%, it means that the R equals 6. R equals 6. The percent is taken care of by this 100 on the year already. So the R is always given as a percentage. So this formula is when the R is given as a percentage. The next thing is the time. This thing is very important and gets people a lot of the time. This thing, the time. Since the rate is a per annum rate, it's going to be a per annum rate. The time has to be in years. The time has to be in years. Well, for example, in this question, where they gave you 6 months, you can put T equals 6. 6 months is half of a year. So T equals half. Very important. If they give you 24 months, that's 2 years. If they give you 18 months, that's 1.5 years. So T equals 1.5. Important thing here is that the T has to be in years. So in this case, the 0.6, the T equals 0.5, half of a year. That's the P. All right? This thing is your P. This is your P. This 6 is your R. But the percentage is already the 100. And so you can calculate the interest after 15 months. The interest at the one, the principal amount, which is 1498, times the R, which is 6. And the percentage in the 6 is already on the year for the 100. Times the time, which is 0.5. Some people do this question and put 6 for the time. No, time is half of a year. 6 months is 0.5. 6 over 12. That's 0.5. That's what you're working on. That is it. Let's go to the graph. With a fraction, it's 1498 times 6 times 0.5. Putting that over $44.90. But God, let's know time again. Total amount of money, this is the amount after 2 years. Total amount of money is going to be the principal amount plus the interest. That's what I want after 3 years. So total after 3 years, it's going to be equal to the principal amount plus the interest after 2 years. And the interest is PRT over 100. That's the total in there. In this case, P equals 3. That's what they calculate, the total amount. Principal amount plus the interest. This is the interest. Understand that? This is the interest. We are adding the interest. Principal amount plus the interest. That's how we need to calculate. So the principal amount is the same. 1, 4, 9, 4, 9, 1, 4, 9. Plus, what is the interest? In principal, 490 times the rate of 6 times the time of 3, that's about 3 years, the P equals 3 divided by 100. That's what we calculate. There's another way to that. We're doing principal amount 149 plus fraction 149 9 times 3 over 1 7 67.64. That is total. Now, another way we could have done it, right? Is this. That's it. Rather than a full calculation, we could say, okay, since this is the amount after 6 months, right? Then it means that 1 year is this amount times 2. 4.94 times 2. That's for 1 year. And so 3 years now, it will be 3 times that. See that? So to multiply by another 3 for 3 years. This will be the interest after 3 years, and you could add it to the principal. So that's another tool you could have done. But that's and that 36 months amount, double to get a year. Much for a year. That's interest for a year. And then you want for 3 years, they multiply that no amount by 3. That will be the interest for 3 years. And then you add it back now to the principal amount to get the pay. But we settle with this. All right. Let's continue. How long will it take before the investment reach this amount? It's supposed to be easy, you know. So look here. This figure basically 10 times this figure. So this figure is for half year. 10.5 years is 5 years, don't it? You don't have this for 5 years. But you can see that? So this is 10 times that figure. So 10.5 years. 10.5 years is 5 years. Well, let's say anyone know that. They want to calculate from scratch. But that's not the reason behind that. Good. So let's say anyone knows that, right? And so the key thing here, you know, guys, is that the word earn means that is the interest amount. The amount earned is the interest amount. So this question is saying, okay, what is the time when the interest is this amount? We can transpose the interest formula to make time the subject and put this figure as a figure. We're going to get the same fact. All right? So this question we could just figure exercise. But let's say I realize I didn't give you that figure like how the calculation. Use the formula I equals PRT divided by 100. This question said that the interest is 449.4. All right? And you're trying to find the time. You want to make time the subject. Multiply the 100 here. We get 100 times I. And then take the PR and divide it under here. Divide that by the E and the R. That gives you the time. So put it in the values inside here to find the time. So it will be 100 times the interest that they tell us is 449.40 Divide that by the principal of a principal again, 1498, and also the rate of 6. That will be the time. So that this is going to work out in 5 years. Equals. And question say, how long? They cannot say T equals 5. We say 5 years. The how long? You say 5 something. You cannot say 5. So write out 5 years. So we work out to the 5. Let's look at it. The fraction 100 times 449.4 divided by 1490 times 6. 5. But as I said, the OR method is to say, the amount that we got up there, which was 44.90, equivalent to 6 months. What is it? Times that by 2. Times this by 2 to get a year. And times it by 10. Times it by 10. Times this by 10. But this is what to become this. Means then that you would have 449. That's what it will be a 4, right? That's what that's 449.40 equal to 60 months. 60 months by 12 is 5 years. Equivalent 5. So I cannot do that way as well. Recognize the multiple that is 3 of the multiple of 10. And so could have done that as well. Question 1 done. Next question. This question says solve for x. Solve means make x a subject. Remember, solving a simple linear inequality like that is the same as if you're solving this that equal. You're trying to make x a subject. The only thing with this one you have to remember is that if you have to multiply or divide with a negative number, you have to reverse inequality sign. That's the only thing to remember with inequality. So the same step, you're trying to make x a subject. Like a group in x on the same side. So let's say we group in x on this side where it is positive. It's going to remain positive. I'm going to take this minus x and bring it over this side. Sign don't change. I'm going to have 5x plus x. This x goes over here become plus x. This over here is 8. Take this 2, bring it over here, become negative 2. 8 minus 2 is 6. That's an equal to this becomes 6x. We can divide 2 by 6. There's no need to reverse the sign. Divide 2 and 6. We get 1 less than or equal to x. Read the other way, right to left, to say the x is greater than or equal to 1. Or, if we want to, we could have used x on this side. So, okay, I'm going to leave this minus x over here. The negative x. This 5x comes over here, minus 5x. Less than or equal to this 2 is there. This 8 goes over, becomes a negative 8. This becomes negative 6x. Less than or equal to this becomes negative 6. Let's make x a subject now to divide by a negative 6 and reverse the sign. Here now, I would have to divide by negative 6. Because that's a negative number, I would have to reverse that less than or equal to sign. But equal to remain 2. When I divide this, that negative 6 becomes x. Sign is reversed, the greater than or equal to. Divide negative 6 by negative 6, it becomes 1. Same answer as that. All right? Same answer. Over here, when I divide by the negative 6, by the 6, there was no need to reverse the sign over this one. No need to reverse the sign over here. But I'm dividing the positive number. That is it. Next one says, show your solution on the number line. So the critical value is 1. So you're starting at 1 right here. Put a circle on the 1. Line up on the but because the equal is a part of inequality, it means that 1 is also a valid value. To show that the 1 is a valid value, you shade the circle. The equal was not there, we would leave the circle unshaded. And then you want greater than 1, you put the arrow pointing to the right. Over here, values are greater than 1. So that's inequality. Greater than or equal to 1. Simple as that. All right, if equal was not there, then this circle will be left unshaded. All right, if it was just x greater than 1, we'll put an unshaded circle on the 1. Like that. Very good? All right, let's continue. This one wants us to expand and simplify this thing. Expand and simplify this thing. All right, you're going to work out this bracketed term. Note that here we multiply with a negative 3. All right, not just a 3, a negative 3. We're doing this first. So the 2x times this x gives us 2x squared. 2x times this gives us 10x. Negative 3 times x is negative 3x. With negative 3 times negative 4. This is a positive 12. No people put negative 12, let's say no. Learn from a mistake. Negative times negative is positive. We consolidate these values in here because them just simplify. This is the only square term there, so that's 2x squared. These two give me 7x. And that's a plus 12. And that is it. Those cannot be simplified in the first. Positive. But we can try more in the future. All right. Next one. Simplify this thing. When you divide numbers with the same base, you subtract the power, right? You multiply, you add the power. Let's work on the numerator first. That's what we do. It becomes equal to the 3 times 4 is 12. X squared times x cubed becomes x to the 5th power. Understand that? And you add the power. Divided by 2 times x. Here now, right, what this 5 is. This 5 is 2 plus 2. What this is. Right? Here now we're dividing. 12 divided by 2 is 6. When you divide indices, you subtract the power. It becomes x to the 4th power. Why is it x to the 4th? Because it is x to the 5 minus 1. But this has a power 1 on it. All right? That's what this is. But this is the answer right here. Nice and easy. All right? This one. Write as a single fraction. When you add in fractions, whether they are numerical or algebraic, you want them to be related. Related means that they have the same denominator. So they have the same denominator, they can just add the numerator and put by the common denominator. So to make this one and this one have the same denominator, I'm going to multiply this denominator up here and down here and multiply this denominator up here and down here. So like I'm multiplying this one by 5 over 5. I'm multiplying this one by 2 over 2. And then both will have a denominator of 10. This one becomes 5x plus 5 over 10. That is 5 times e to d, give me that. And this one becomes 2 times d, which is 10 minus 2x over 10. What are the same denominator? I can put back that common denominator and then add the numerator values algebraic. There's 5x plus minus 2. 2 minus 5 minus 2, that's 3x. And 5 and 10 is 3. 3x plus 15, what is it? All over 12. So I factorize the numerator and put 3 into x plus 5 over 10, that's 5. Then what is the lever going to do? Like it. Factorize it with 3. That's what it is. All right. Next question. Factorize this completely. There's a difference of 2 squares as it is in, but you must always use common factor first. There's a common factor 4 in this. I'm going to factorize the common factor 4 first. I'm going to get x squared minus 1. Then inside, you know the difference of 2 squares. This 1 is the same as 1 squared. But remember that. So we have the difference of 2 squares in here. So you're not done yet. So become the common factor 4 into difference of 2 squared become the difference of the numbers and the sum of the numbers. That is it. Factorize complete. That is the answer. Huh? No, they don't put the plus in front. No, but look here now. It's good practice to put the minus in front. So when you're doing the difference of 2 poles at a higher level, all of them start with the difference. For example, the difference of 2 cubes, like a cube minus b cube. Is a cube minus b cube. Start with a minus b, becomes a squared plus ab plus b squared. That's what it is. You have a to the fourth minus b to the fourth. Again, that starts with a minus c. Then it is a2 plus a squared b plus ab squared plus b cubed. All of them start with the question like that. So this is the first one. A squared minus b squared is a minus b times a plus b. That's the first one at CSEC. But at add maths and pure maths, you have to do all the other power like that. All of them start with the difference of the number. You get me? Good. All right. That's that. Very good. Moving right along. What is supposed to reach 24 marks a month? We're going to do this question still. By the way, we're going to have a class. We're going to do sets. So sets features prominently on the multiple choice paper. There are about maybe 8 to 10 questions on sets alone on the multiple choice. We don't set sets on paper 2, so it's on the multiple choice. So we're going to have a class. We're going to just do 4 hours of sets. So straight sets we do about 4 hours. You know all those multiple choice questions. All right? It's pure sets. We're going to have that session before the paper 1 exam. I might not be before the paper 2 exam, but I'll certainly be before the paper 1. We'll cover 6. It's not coming on the paper 2, but on the paper 1. All right, let's go. This one says, when the diagram below shows the number of students is form 5. I think I'll be before the exam starts. After the exam starts, yeah, everybody together because you have exams. Then maybe want to get the children together on a weekend and become hard. So I like to do everything I need to do before exam starts. Don't come to a class. All right, so that's the Venn diagram, right? I'm going to try to explain it too much. We have a section where I go through steps properly, right? So let's get it. Right, so these are the sets, these are the values in there. We have what call subsets. Because how many students visit Dominica only? That's right here, 10. Dominica only, 10. 10. Write an expression in terms of expert. Represent the total number of students who visit Canada. With your T plus X, Canada. T plus X. T plus X, visit Canada. But statistics also visit Canada. Two associates visit nowhere at all. No visit none of them two places there. The total in the survey is all of these added together. Yeah, man? Next part now says Give that 25 students in Form 5, like 25 students in Form 5. Calculate means that everything in here must add up to 25. That's what it means. That means that it's 3 plus x plus 10 plus the 2x out there must add up to 25. That's what that is. All right? So this and this is 3x, and this is 13. 13 plus 3x plus 25. Subtract the 13, we get 3x equals 5 by the, we get x equals 10 by the number of students into the following. This is the union of P and E. P and E union is up inside your alone. But x is no 4. Now that x is 4, know that this is actually 4. So this total is 17, not it? The union is 17 right here. This union, everything together. 17. This is the intersection. That's the symbol for the intersection. Here the combine. We'll do the intersection right here. X. 4. This 4. This is the complement of the union, meaning what is outside C and D together. That's 3 out here. That's 8. 3 times 4 is 8. Right? That's 3. That's why I will get. This one is the 2. 3 times 4. This is that's how we get. This one is up. This one is 3 X is 4, 17, X is 4 here, X is 4. That's right, 4. All cases, so now get the values. All right, next question. I'm going to do this one. Construction. Let me get to my question. We are supposed to do this after the math exam. There you go. All right. But I always say, when you get something to construct, check it first. Then you construct it. All right. This one just wants a square. Upside 6 centimeters. Use rule and pen to compass, construct accurately a square. So EF is 6 centimeters. So this corresponds to a square. EF is 6. EF which is 6 centimeters. Everything is only a 90 degrees. 90 degrees. Then also construct this. It can fit, and then do the parallel construction. This over to this side. This over to that side. Let me show you. I'm going to construct this first. I'm going to transpose this distance up here and get an arc out here. Transpose this distance over here and get an arc out here. And then join up everything to get the square. Huh? No. You can put it the other way around. Doesn't matter. Doesn't matter. All right, let me construct that. First, I'm going to use my ruler and draw that first 6 centimeter line. Now I'm going to construct the 90. I'm saying for construct, right? I'm talking to you. I'm going to construct the 90 from this end. Remember, this program, construct a 90, construct 60 and a 60, bisect the second 60. 60 plus 30 with 9. That's how we need to do it. The other way to do it, right? You ready? I'm going to construct a big 120 all the way around the first. All the way around. We will compass to this point. Cross that arc. That's 60. Move the point up here. Cross that other arc out here. And second 60. I'm going to bisect the second 60. I'm going to change the color. The bisect the second 60 up here now. An arc up here. Straight line to that intersection now will be 60 degrees, will be 90 degrees. Sorry. Undo it. I'm going to lose that. I'm going to use this line. Straight line through this intersection now is 90 degrees, that black line. I want that to be 6 centimeters. So if I'm going to get the 6. Use the ruler. You can measure the ruler with it on it. But I'm going to do it this way. Remember the compass. And ohm it out to 6. Lock it. Then let me make an arc with the blue. Put the point here. Rotate this over. Cross that at this 6. Right, this is good. What I'm going to do now, that 6, I'm going to transpose that 6 length over to this end of the line. Make an arc. That is 6. Then now, transpose this distance of 6. This distance that is also 6. I transfer that distance up here. I transfer that distance up here. Then about the intersection there, I have my square. And trying from here to here. Run from here to here. That's my square. I can label it up. E, F, E. Everything is 6. I was talking to 6 centimeters, 6 centimeters, 6 centimeters. Next part says you have to measure the length of the diagonal FH. FH is across here. Now use the rule and the compass and do it here. One is across here. Lock it. Measure what it is on the way. The point 1 at 0. That's given me 8.3. 8.3 centimeters. You have 8.3. Right? This is 8.3 centimeters. Okay, actually calculate it, you know, see if it's right. But part of this theorem will give us this diagonal. Square of 6 squared plus 6 squared. Let's see what we get by calculating. So we'll get by calculating. Square root 6 squared plus 6 squared. 8.45 or 8.5. Good enough. Let's change this to 8.5. We do construction and class. All right, so here why that should have been last for my agenda because that is not certain. So we'll get to the short topics and first, and then we can maybe do something. But construction, hard like to come easy, so don't take it off and everything like that. But that's it, still see, can do. All right. But the class that we did, we actually recorded that class. No, so the video is there. The video is in the group. So what I'll do, I send it again in the meantime. All right. Remind me to send it again. All right, let's go. Number four. Number four says diagram below shows a map of an island on 1 centimeter square. I have 1 centimeter square. So it's a map of an island, right? Each of these grade is 1 centimeter. For the base color says. Says 18 centimeters the length LM as shown the diagram. LM, that's the distance across here. Let's see the count square. 1, 2, 3, 4, 5, 6, 7, 8. 8 centimeters. Easy, 3 marks. 8 centimeters. Estimate by counting squares the area of the map as shown in the diagram. If you want to count them 1, 1, 1, 1 and do that, fine. But I like to identify some areas and so on. If you not want to finalize with your arm or whatever. You get me? Some big figures are counting square, you must actually count the squares like this. You can literally pick up some shapes in it, like pick out some squares in it. Like for example, we pick out this square out of it, break it down into shapes. You still have to count the dimensions of these shapes. We take count in the square. So that's a rectangle inside here. You see 1, 2, 3, 4, 5. That's 5. Next 1, 2, 3, 4, 5. 5 by 5. But over here, this is like a semicircle to me. Over here. I'm going to treat this like a semicircle here. That would be the diameter. 1, 2, 3, 4, 5. If the piece is I'm going to make it a semicircle radius. It's a semicircle radius 6. All right. This look like I'm doing it. No, that's not the way that you absolutely have to do it, right? Don't get me wrong. That looks like a rectangle. We have a triangle inside here, so almost another small triangle inside here, so almost. So this triangle is a 2 by 1. This triangle is a 2 by 1, 2, 3, 4. 2 by 4. And then this piece down here. We have a rectangle again. You want to count the squares that are a problem, right? You can count the squares if you want. No problem. That looks like a rectangle. I like a triangle here to subtract, which is a 1 by 1. We call it 1 by 2. And this is 1 by half. And this one up here, which is a rectangle. I call it 1 by 2. Like a triangle, like a 1 by 1. All right. So maybe I'm doing it hard. Then of course, the straight on my line, right? No problem. So I'm gonna say I have a 5 by 5 in here first. Plus over here, I'm gonna say it's a half of a circle. I'm gonna use half pi. The radius is 6. No, the radius is 3. The diameter is 6, the radius is 3. I'm gonna say the radius is 3. That's it. It's like half of a circle. Half of pi r squared. The diameter is 3. Half of pi r squared. And over this end, it becomes a angle of a 2 by 5 minus this triangle here now is half 2 times 4, which is 1 times 4. And also minus this half of 2 times minus another 1 down here. So that covers over here. Then I have up here and up here. Up here, look like a rectangle at 2 by 1, which is 2. Minus, it looks like a 1, half and half minus 1. Plus down here is a 1, 2, 3, 4, 5 by 1, which is 5. Minus, this is like a 1 and a half. Let's call it 1. I'm going to give them that. I'm going to give them that. You tell me what you got and you count them up. You tell me what you got and you count them up, right? All right, I'm getting 25 plus 0.5 times pi. I'll give them the nearest whole number now, as them say square, times 9. This 3 squared is 9. This is 10 minus 5, that's 5 in there, so it's another 5. Then this is another 1. That's another 4. 49. What y'all got? 47, 46, 45. Who else? What else? All right. Let me use 40. Let me use 47. Yeah, my engineer get to give. How are you counting? I'm gonna say, all right, I'm gonna use, let's use 46. Let's use 46. I don't like these when they don't give you some shapes that you can actually, test the accuracy of it. I like the ones where they give you shapes. There are shapes there that you can actually use. Let me use the 46, right? All right, it says now, on the island, the actual distance LM is 20 centimeters. Complete the statement below. So remember the LM that we got on the map was 8, right? So it means that map to land. Map to land is 8 centimeters to 20 kilometers. I want to see what 1 centimeter is. Right? So divide 2 by 8. All right? So divide 2 by 8 to get 1. So divide 2 by 8. Divide 2 by 8 to get 1 centimeter. 20 divided by 8 is 20 divided by 8. 2.5. So the answer right here is 2.5. But understand that? The 8 centimeters that we measured was 20 kilometers. So it'll be like a ratio business. Next one. Write the scale of the map in the form 1 to something. In other words, they don't want any unit. It's 20 kilometers. They don't want any unit. 1 to something. Remember now the scale is 1 centimeter to 2.5 kilometers. We have to convert this now to 50 centimeters. So we can wipe out the unit. That's what I want. 1 to a number. Meaning we don't want any units. So in order to cancel the units, I'm bring both sides of the scale to the same unit of measure. So we're going to bring this kilometer to the centimeter. So it's 1 centimeter to. Let's go step by step. First, they multiply by 1,000 to get meters. Multiply it by 1,000, it becomes 2,513. 2,500 meter. Multiply by 100 to get centimeter. Now 100 centimeter become meter. So 1 centimeter to 2,500 centimeter. Then the centimeters can be dropped. So it's 1 to 250,000. There's 250,000. If you want, you could convert the 2.5 kilometers to centimeters straight like this. Watch it. Kill him, dear mister. Don't commit murder. And some people say, kick him down, mister. Don't commit murder. Right? So you put the 2.5 on this. And you want the decimal point to come here. To come after this, right? So you go 1. So 1, 2, 3, 4, 5. You put it in 0, 0. This is 4 0 at 3. You see that? So put it that way as well. All right. Next part says, what distance on the island will be 3 centimeters on the map? What distance on the island will be 3 centimeters on the map? So we're using this scale still. You see there, 1 centimeter is 2.5 kilometers. What distance on the island will be 3 centimeters on the map? They want this to become 3. They multiply the scale by 3. Multiply the scale by 3, you get 3 centimeters. So multiply this by 3, we get 7.5 kilometers. Wanna go to that? Then down here now it says, what area on the map, what area on the island is equivalent to 3 centimeters squared on the map? You can do this a nice way now. Look at this now. Watch this now. 3 centimeters squared is the same as 3 centimeters times 1 centimeter. With 3 centimeters, it's 7.5 kilometers. Times 1 centimeter is 2.5 kilometers. They multiply that all together. Understand that? I've taken a 3 centimeter squared area. That's what the dimension would be. A 3 centimeter squared area, dimension wise, can be a 3 centimeter times a 1 centimeter. 3 centimeter side is equivalent to 7.5 kilometers. 1 centimeter side is equivalent to 2.5 kilometers. So this is the area on the map that we will get. 7.5 times 2.5. That's 18.75 kilometers. But understand that? I'm going to show you another way you could do it. You could take the distance scale and convert it to area scale by squaring both sides. Let's do it another way. I'll show you the one day how to go from distance to area. Let's see it over here. So the distance scale. For distance. One centimeter to 2.5 kilometers. For area, you square this one. There's 1 centimeter squared to 2.5 squared kilometers squared. That's a scale for area. 1 centimeter squared to 2.5 square kilometers squared. You want to know what 3 centimeters squared is? You multiply it by 3. Multiply it by 3. And then you will get 3 centimeters squared foot, 3 times 2.5 squared kilometers squared. We're going to get the same answer that we had before, 18.75 kilometers squared. That's another way to do it. 100 distance scale to area scale, and then multiply by 3 to get the 3 kilometers squared. Right? Or you could take the 3 centimeter area that I gave you, 3 centimeter squared area, and write as a product of 2 dimensions. That would give you 3 centimeter squared, 3 by 1. The 3 centimeter side of that area is 7.5 kilometers. 1 centimeter side of that area is 2.5 kilometers. So the area on the land becomes this times that 18.75. If you do this calculation over, you're going to get the same answer. Look, let's look at it. 3 times 2.5 squared. There, 18.75. All right, so I don't know which way you prefer. Maybe you prefer to do the area scale, right? Squaring the distance scale. And then you multiply by 3. So you could take the area on the map, break it down into 2 dimensions on the map. You see what each of those dimensions in the island will be. Multiply by 3 dimensions. Right, so it's all of these. These are our method over here. All right, next question. This one. It's a solid geometry question. It says, diagram below not drawn to scale shows a prism, the cross section PQRST, and the length of 20 centimeters. It is made of a rectangle PQRT and a semicircle RST, such that PQ is 6 and QR is 5. Everything that they have said is on the diagram. But a semicircle up here, half of a circle. The diameter is 6, so the radius is 3. Up here, so the radius is 3. The radius of this semicircle is 3 centimeters. This is the length of the prism from end to end. So this is your L. Remember, the formula for object is uniform cross section. That volume is cross sectional area times the length. We have curved surface area. It is the area on the side of this thing. It's perimeter of the end and the length. Then total surface area, the want it is the curved surface area for 2 end areas, the one at the front and the back. Curved surface area. Curved surface area here on the side for the 2 ends, 2A. You have 2 times the end area. Then key formula here, we want everything with object with uniform pattern. Let's see what I want us to do. Remember, this here is your L. L equals 20. It says calculate the area of a cross section. That's the end area that I want, the area that fails. That's the A in this formula that I want, the A. That's what I want here. Let's work it out. So the end area equals the area of this rectangle plus the area of the semicircle. We have a rectangle is 5 times 6. We have a semicircle is half the area of a circle. Half 5 times the radius. Did they tell us to find anything? 3.14. So it's 30, 5 is 30, plus half and 3.14. And the chief radius is 9. That's what we're working. So 30 plus half is 0.5 times 3.14 times 9. That's 44.13. 44.13 centimeters squared. That is your end area A. says an engineer needs a similar prism whose volume is not to be more than 900 cm3. Estimating centimeters the length of the longest piece. So it means that the same in this question. They want the volume to be 900. How long it has to be? So the volume is n area times length. This question is trying to find a length. We divide by the area. So the volume is 900. So this 900 is the volume that you want it to be. So A is this. So the length that you want is the volume over the n area. Therefore, the length is the volume of 900 divided by the n area of it. Part of 4.1. Can't get longer than 900 divided by part of 4.1. 20.4. That's all long they want. Can't pass, otherwise it's gonna be more than that. Like this. You basically find out what length to make the volume 900. That's what we do. 20.4. All right. So this 20 wasn't valid because this didn't ask us for the volume of this piece. Right? They asked us for the volume of a piece. I watch the section. That is it. Everybody good? They didn't ask us for the next sort of thing. Number 5. Number 5 gives us the diagram. In the diagram below, not drawn to scale. ST is 6. And make sure everything that's here appears on the diagram, right? ST is 6, that's right here, 6. WR is 11.2, that's here. WT is 14.8, that's here. And this angle is 90 degrees down here. So we have 2 right angle triangles in this one. This is a right angle triangle right here. 1 right angle triangle. Another big right angle triangle here. Number 1, to work in a right angle triangle, you can use Pythagoras theorem. You can use 2 part for it. 2 right angle triangles. If you have to work in this triangle, you have to use sine rule or cosine rule. You have to work in that. When section 1, you don't get. Section 1, trigonometry, it's always right angle triangle. Alright? Section 1, trigonometry. This question says, calculate giving your answer to 1 decimal place, length of RS. RS is this piece. To find RS, I'm going to work in this big triangle. Find the whole of this length here, so, and then subtract this. Everybody can understand that? Understand that? Good. And that big triangle, we have 2 of the sides. This is what we do. This is what we do. All right? So let's set it up. RS is equal to RT minus 6, don't it? We're trying to find what RT is. What? Yes. Now, using Pythagoras theorem, RT becomes the square root of this hypotenuse, which is 14.8 squared minus 11.8 squared. Pythagoras theorem. But after that, this is the hypotenuse. Hypotenuse squared is equal to this side squared plus this side squared. So if you want to find this side, become the square root of the hypotenuse squared minus this side over here squared. You can't keep it like babies anymore. You have a small space to work with. You have time to work in a 1 million line to be expected. You can do it in 1 million. So this calculation will give you RT from Pythagoras theorem. And then the R, the 6, the RS now is just 6, therefore minus 6. Therefore, RS equal to, let's get it out here. square root 14 point squared minus 11.3 squared. What am I gonna subtract 6? That's 3 point and for one decimal place, so that's 3.7. Then we do. But RT works for the 6 is what RT is. RT is 9.7. 9.7 minus 6 is 3.7. That's it. But what? Next part now says the measure of angle RTW. Which angle is that? RTW is right here. RTW is right. Let's call it theta. Instead of RTW on the theta. Let's call it theta. Tell the examiner that we're calling it theta. If we call it theta now, work it out. We're going to work in the big triangle again. And we can use these two sides. Opposite to hypotenuse and the big triangle here. Don't it? Opposite to hypotenuse is sine figuration. That's all? Sine. We're going to say sine theta equal the opposite side of 11.2 over the hypotenuse of 14.3. Theta becomes sine to the minus 1 of the 11.2 over the 14.3. Sine to the minus 1, sine to the minus 1 of a fraction, 11.2 over 14.8. That's 49.1. It's a one decimal place, everything. But I want to put 49.2 degrees. 49.2 degrees. Is that angle right there? Anything else? No, let's stand up. That's it. It is one more thing than I wouldn't need it in this case. Let me read. Well, that is. What go to that? All right. Next question. This question says diagram below shows the triangle ABC and its A prime, B prime after undergoing a different transformation. That's what I'm telling you what it is, right? Looks like a rotation to B. It says right on the corners of ABC. That's this one. Right them up here and copy it. So A is 3, 2. Try to get A is B. B is 6, 2. 6, 2. C is 3, 4. C is 3, 4. We're going to call it the flat line. The top of them. Use them down here. Right. Well, A prime, B prime, C prime. 3 marks. All right. What you want? That's what you get. A prime. This point. 2, negative 3. 2, negative 3. No, I always put X value first. B prime. Here. 2, negative 6. 2, negative 6. B prime. Right here. 4, negative 3. 4, negative 3. Up to this down. It's careful transformation of A and C of A prime, B prime, C prime. Let's look at it. What transformation takes us from this to this? Looks like a rotation. 90 degrees clockwise about the origin. After that, not a reflection. Remember, ABC and this is anti-clockwise. ABC and this is also anti-clockwise. It is not a reflection in a line. The reflection in a line always is a reverse. Not an enlargement clearly, because there's no change in size. It's not a translation because the thing is curved. Translation don't turn on. So it's a rotation. All know is 90 degrees. But AB, for example, like this. Use already. AB like this has become AB like that. Then we turn down 90 degrees clockwise. The question is where's the center of the rotation? After the center of rotation. Usually it's the origin right here. We want to check it. We like to rotate in the coordinate. The coordinate of A, for example, is 3, 2. But take this L looking thing and rotate it down here. This piece is going to come 3 down here, so. And it's at the end of it is going to come across the there, so. It is correct. Let's take another point. B, 6, 2. But take those 6, 2 coordinates and rotate it 90 degrees down here. This horizontal is going to become vertical. This at the end of it is going to come out here. Takes it out to the prime. That confirms that that's the center of rotation. With a clockwise 90 degree rotation about the origin. A clockwise 90 degree rotation about the origin. Remember, clockwise rotation is also negative rotation, right? Anti-clockwise is positive. We could have instead say, we have instead right here say, negative 90 degree rotation. Wow. Right? Clockwise rotation. And turn all the way around. Turn is one, right? Turn is 180 degrees. So, the arrow here, turn is 180 degrees around, but the turn first, the piece arrow. It's not 180. It's turn all the way around. But a piece turn all the way around. When it was 90, years of computation and turn all the way around. But don't facing turn no facing south. Well, you know it's 90 because this was horizontal first, it is now vertical. The tail turn 90 degrees. Yeah? Right. Okay, what else I want us to do? That was our solution translation. Oh, it's on the graph, draw the line x equals 1. X equals 1, the vertical line through 1. X equals 1. X equals 1, vertical line through here. Equals 1. We want to perfect the triangle, don't we? Triangle A double prime, B double prime, C double prime. These are 3D separation. We want to perfect that one. So do your reflection one point at a time. Unit distance equals object distance from the mirror line. So A, for example, is 2 units to the line. We're going to go 2 units on the other side here. That's where A double prime is going to be. When see the same 2 units, going to go 2 units on the other side here. So B double prime is coming here. Then you know, B is 1, 2, 3, 4, 5 units. I'm going to go 5 units on the other side. 1, 2, 3, 4, 5 coming out to here. Coming out to 4. Out to here. The length here and the length here must be the same. These are the points I make. Yeah, like, you don't want to ruler. Use the ruler. Don't do a triangle line. They won't draw a triangle line. I say double time triangle. I just don't want to forget. Create one geometry relationship in the shadow. Like that, equal in every way, that the same area, that the same perimeter, the same the angle is same. That equal in every way. That's right. 100 in steel, in dimension. That's what they're doing. Yeah, equal in every way. So that they have the same area as a geometry relation. They have the same area, same perimeter, same three side, same triangle. Without setting up something like that. All right. Number 6. This is the number. The table below is the number of cars sold in a country in 100 from 2010 to 2014. These are the figures. Question says we are to use that graph. Complete the graph. We're going to fill in the 20, right? 2013 is 60, so you need to find 60. Every 2 centimeters is 1. So I say there are 10, every 2 millimeters, every two of these is 1. So there are 10 lines, with 5, 10 lines divided by 5. Each of them is 1, 2, 3, 4, 5. Every 2 is value. That's right. 15 is on this line. The next dimension was 16 right here. 16. 2013 is 16. 2013 is this line up here. You know this line across here. We're talking about this point. That's the point I want. Right here. The next point is 30. We're going to put this in 30. 30 is all the way to the line of 30. Almost 40 minus here. We're talking about this point. We do that complete. Connect them to one these three. Here. Join these two. That's a shoot. All right, completely. Between these 2 consecutive years, was there the greatest increase in cars sold? This look like it. Let's let the numbers tell us. Here was a reduction of 10. Sorry. Here was a plus 16. Here was a reduction of 10 again. We got plus 16. What's it? The greatest increase from 2011 to 2010. 2012, sorry, right? Right inside here. 16. 2011 to 2012. 2011 to 2012. The greatest increase. Now after what piece of a graph we use to determine that there are greatest increase? Length flow from the line. This is the longest line segment. And also the steepest gradient. Longest line segment. We have greatest increase. Proof is on one. Longest line segment with a positive gradient. All right? Next part says, what is the total number of cars sold in 5 years from 2010 to 2014? Adding them up. Adding up these figures. These figures are added up. We're talking about 100, right? Add up these figures. What is add up to? What is add up to? Total. Total. What? 110. 101. It's up to 101, right? 101. All right. Let's tell it. Total is 101. 101. We have to put on the 20 upon it now, because it's 100. So you have to add on the 20 on it, guys. 10100. There's 10,100 cards. The total number of cards, 10,100 cards. 101 in the table is 10100. See there? It's 100. 10100. 10100. You understand that? You can't put 101. 101 is wrong. 10100. It's 100. All of these figures, this is 1900. It's a 1000. It's a 2600. It's a 1500. It's a 3000. Bigger than 100. So the other people saying 101, 10100. 10100, you put on 2 zeros. On the 101. You put 101 as the answer wrong enough. Right? Put on 101 is wrong. That is it. You put on the 2 zeros on it. 10100 start. Right? That's it. If you go and write on the word 10100, that's fine. It says the mean number of cars sold from 2010 to 2011 is 22.5. How many cars were sold in 2015? So that would do, right? Watch this now. I set up the mean. So the mean to 2015 would have been total up to 2014, which is 101. 101, sorry. Plus the amount sold in 2015, right? Divided by how many is that? How many years is that? We have 1, 2, 3, 4, 5. One more makes 6. So we divide that by 6 to get the mean. Divide it by 6. That means they're telling us it's 22.5, 100. 22.5, 100. So from this, we're going to file the 2015 figure, right? You understand that? 2015 figure. Total so far plus the 2015 figure divided by 6 is equal to the mean. They are giving us the mean of the 2015. We don't know the 2015 figure. So at the 2015 figure, the total that we have so far. Get me? I will try to find what that is. So the x that we want to be equal to multiply the 6 up here is 22.5 times 6. You subtract the 101 minus 101. And whatever I get for that, they put 100 behind. 100. Up here, as I said, I could write 10100. You write this, or you write this. All right? Whatever this record is the answer. They set up a formula for the mean. Equate it to the mean, and they transpose to find what they do. That's what it is. After that, are you okay? All right, I'm finished with that part. We'll come to our part B, which is our coordinate geometry. Question says, a line JK has this as its equation. Determine the gradient. To get the gradient, you need to put it form y equals mx plus b, right? I divide by the 2. We divide by that 2 or multiply by half, same thing. Divide by 2 to get y alone at the top. We're going to get y equals 5 over 2x plus 3. That's the gradient. The gradient of the line M1 is 5 over 2, the first line. 5 over 2. Let's go on for 2.5. That's gradient. All right. Next part says another line, let's call that line 2, is perpendicular to the first one and passes through this point. Stay the gradient of the second line. Negative reciprocal of this one, note it. You see here, the gradient of line 2 is minus 1 over the gradient of line 1. Perpendicular lines have negative reciprocal gradient. You do this calculation, you simply flip this one and change the sign, become minus 2 over 5. Come on, we have to do the mathematics easily. Perpendicular lines have negative reciprocal gradient. Flip the one that you have and change the sign to get the other one when they are perpendicular. Then it says, now what is the equation of the second line? This gradient and this point for the second line. We're using y minus the y value at the point equals the gradient of line 2 into x minus x value at the point. This is the point. This is the xp, yp. Because y minus the yp value here is negative 1. Negative 1. That becomes a plus. Equals the perpendicular gradient of line 2 is minus 2 over 5. Into x minus x value at the point is 5 right here. You might have to know this formula that the BFF for each piece of a line, we have a point and a gradient. And then we're working this out now. We can take this 5 and multiply it across here. Well, this minus minus is a plus. Minus minus is a plus. That's a plus. Multiply by the 5. Take the 5 and multiply across here. It becomes 5y plus 5. Take the minus 2 and multiply it inside this bracket. You get minus 2 times x is minus 2x. Minus 2 times minus 5 is positive 10. We're going to get 5y equals minus 2x. Then this 5 goes over and subtract from this 10, give me 5. 10 minus 5 is 5. That's my equation. 5y equals minus 2x plus 5. So I divide by the 5 and put y equals minus 2 over 5x plus 1. That's fine as well. Go on to that. Divide by the 5. That's it. All right. Next question. Number 7. Statistic. It says the diagram below shows how the minutes taken by all students to complete a science experiment were recorded in group. You know, data group, you don't know the actual value, everything we do is estimate, right? We start the community frequency column for natural going to ask us to complete it. Here, complete it. Complete it by adding up frequency. Remember, this is just counting column. You're counting the people as you go from group to group. Community frequency is counting. So 3 plus 5 is 8, won't it? Then 8 plus 7 is 15. Then 15 plus 10 is 25. And 25 plus 15 is 40. 40 plus 8 is 48. 48 plus 2 is 50. That's given to the column completed. Next part says, on the grid on page 23, you can have 2 centimeters for 5 units on the x-axis, 2 centimeters for 5, on the y-axis, draw a community frequency curve. Use a graph to estimate the median. Orbital student chosen at random took less than or equal to 30 minutes or less. Less than or equal to 30. We're going to do a less than or equal to graph, meaning we're going to use the upper boundary values. We're going to use the upper boundary values, upper limit values, sorry. with the cumulative frequency. That's what you draw. That's what you draw. The question asks for less than equal information here. That's why I'm doing that. See? How many people took 30 minutes or less? That means less than or equal to 30. Since I asked for less than or equal to information, I'm going to draw a less than or equal to graph. When I'm drawing a less than or equal to cumulative frequency graph, I use the upper limit values with the cumulative frequency. If I wanted less than graph, I use the upper boundary values. All right? So that's what I'm going to do. Those points. All right, I'll leave it. Let's see if we just scale the graph. No, they haven't scaled the graph. They haven't scaled the graph. But they said it is 2 centimeters to 5 on each axis. That's it, right? 2 centimeters to 5, 2 centimeters to 5. Right. 2 centimeters to 5. That is 5, 10, 15, 20, 25, 30. If you go plug in the measure, it'll just go to 40. 30, 35, 40. Same thing up here, so now, same scale. 5 students, 1, 15, 22, 25, 30, 35, 40, 45. 2 centimeters. So the cumulative frequency. Frequency which a student, those are your 50 students. This is how much time to put less than I would. Right? Complete that out. It's less than I equal to time, right? Less than equal to time in minutes. Less than equal to time in minutes. But only is less than half equal to time. All right, let's start the points now. Let's start them in first. The first one is we're going back and forth. Let's now go to 5, 1. 5, 1, 10, 2. Let's go. 5, 1, 10, 2. 5, 1. This is 1. 5, 1 is right here. 10, 2 is 1, 2, 3. 10, 2 right here. First 2 points. 5, 1, 10. 1. 1, 8, 8, 15, 25. 8, 15, 25 are next two values. 8, 15, 25. 8, 15, 25 are the next two values. 15 is 8. 8, 15, 25. 5, 6, 7, 8. Right here. 15. Goes up to 15 here. Right here. 25. 15, 25. 25. 25. 25. Right here. Next key value. 15, 25. We have 4, and we have 40. 40, 40 is 50. 40, 40 is 50. 40, 40 is 50. Next value. 40 is 50. Next 40. 40 is right here. So you have 40 times 40 is 45, 46, 47, 40 is right here. Right here. Then 50. Last value 40 out here. I think just distance, yeah. Right, those are your points. Remember, I must always carry the graph down to 0. The value before this 5 would have been 0 down to 0. Right here. For adding that point. Those are the points. Just need to draw the smooth curve to those points now. I get the O-give shape. Let's do it. Da 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 da. Da, 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 da. That's it. That's it. These are the nice nice. I mean that device that is doing its own thing. Okay, guys. You have to put in this value now. You have to put in that value. But always bring your cumulative frequency curve down to 0. You have to put in that value. That practice that you must do. The value before this 5 would have been 0. I will bring that cumulative frequency down to 0. Yeah. Always bring a cumulative frequency down to 0. Means that no student took less than 0 minutes. That's what that means. All right? Let's go. What do I want us to get from there? I don't want the median, right? So draw the graph. You don't want the median. So since there are 50 students, the median corresponds to the 25th student, right? The time taken by the 25th student. Here, 25. So the median is actually 25 minutes. 25 tells us 25. 25 minutes, right? That's 25 minutes. Just put the lines on the graph. Median student is the 25th student. It's exactly our 25. So this is key. 25 minutes. 25 minutes. Probably that student took less than equal to 30 minutes. I want to know how many students took less than equal to 30 minutes now. And put that over the total of 50 students. So less than equal to 30, we want to say how many students took less than equal to 30. You come to 30, the graph is showing you that. It's 30 here, so you know how many students took less than equal to 30. The graph is showing how many students took less than equal to any time. You want to less than equal to 30 now, from the 30 right here. Come on the graph on this 30 line. I'm going to make it the right here. Across on the graph, we have that. I'm getting 35, 36, 37, 38. I don't know. I can't let them. I'm a structure of a field. Yeah, that's a bit here. Come across on this side. That's 39. 39 got took less than 30 minutes. 39 students. So they don't want to do more, they want to do more to the 50 minus 39, right? We have to know it in the left. 39 over the 50. 39 over 50. So we get 40, we have to get 40. So this is 39 over the 50 students. That's the answer. You can't even find a further lesson. Very good. All right, next one. Next question. No, next question. Number 8, pattern. Let's do this quickly. Give us those shapes. The diagram below shows the first 3 figures in a sequence of figures. You see that they adding on this diamond looking thing to each shape, right? So the fourth figure is to redraw this one and add another diamond piece. We draw about this shape. Let's go copy it down. Otherwise, you can. I'm using up the equipment that I have available to me to do it. I hope I draw the shape and copy it down. And then add another piece. Activate. And put in these dots. There are some dots here. We get next shape to add another diamond, right? Let's put on the additional diamond in here. Bam, 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 bam. Then this line, draw that down. You can do additional dots. That is your figure 4. But go to that. Figure 3 plus 1 more. All right. Next question says. It says the table below show the number of dots and lines for each figure. Study the pattern in the table and complete the table by inserting the values with variables number 1, 2, 3, and 4. Let's see if we can pick up the formula first. All right. This one, these values going up by 3. These values going up by 5. So it's a plus 3, a plus 5. So this column 3n is a part of the formula, 3n. The first figure has 4. 3 times 1 is 3. You have to add 1. 3n plus 1 is the formula for that one. This one is 5n is a part of the formula. I want to add 1 again to get 6. So this column is 5n plus 1. But that's how we get the formula. Good. Going up by 3, so it's 3n. But the first figure has 4. 3 1 3 plus 1 makes 4. This column going up by 5, so it's 5n is in the formula. First figure has 6. 5 times 1 is 5. If I add 1 to get the 6. So it's 5n plus 6. Notice that formula kind of easy. This is the next shape. So we can actually just add the 3 to this. Get 13. Add the 5 to this. Get 21. But I go to that. Or we could have taken this 4. Put on the formula. 3 4 is 12. And 1 is 13. I could put on the 5 over here. 4 5 5 4 is 20 plus 1 is 21. Because that is the next figure. Figure number 4. For this one, I'm going to take the 10 and put on the formula. 3 times 10 is 30 plus 1 give me 31. Good? Take this 10 and drop it on the formula. 51 that, don't it? Then here now, we want to find what the figure number is. We're going to put this formula equals 49. We work out this one over here. We're going to put the formula, which is 3n plus 1 equals 49. Means that 3n is equal to 48. You subtract the 1. Divide by 3, the n is equal to 16. That's all. The n is equal to 16. You take that 16 and drop it on this formula. 5 times 16 is about 18. Plus 1 is 81. That's correct? 81. Question done. See? That is the makeup time. Next question. Number 9. Diagram below shows the graph of 3 lines and the shaded region X defined by the 3 inequalities associated with 3 lines. Equality associated with line y equals 3. That's this line y equals 3. Is this one, which you can understand, because the region is above that line. Greater than means above. And the equal is a part of this inequality because the line here is drawn solid. It's a solid line. But all the lines are solid, so the equal is going to be on all inequalities. Question says, here the other 2 inequalities. So for this one, the region is to the right of x equals 2. So x greater than or equal to 2. But I got to agree with that. I will put the equal on it because it's a solid line. If it's a broken line, you wouldn't put the equal on it. This one is x greater than or equal to 2. Second one is that the region is below the line x plus y equals 10. We're going to be x plus y less than or equal to 10. But you can see that. The next one is x plus y less than or equal to 10. Nice and easy. Easy question. Next part says function p 5x plus 2y minus 3 satisfy the solution set represented by the closed triangular region. Identify the 3 pairs of xy values for which p has a maximum or minimum. These are the vertices I want. The vertices. Maximum or minimum occurs at the vertices of your shaded region. Most know that by now. Let's write them out here. Copy them down. This point up here, let's name them. A, B, C. That is A. A is the point 2, 3. B up here. B is the point 2, 8. C is the point 7, 3. C is the point 7, 3. Those are your 3 points. 3 vertices. 3 vertices are what? Put them right here. 3 vertices are what? That is it. Next part says, which pair makes P maximum? Is either this one or this one, don't it? A clearly out of it, don't it? You want to test A and test B, right? Remember the formula for P is what? The formula for P? This one. 5x plus 2y minus 3. 5x plus 2y minus 3. You want to test at B and at C, right? We're going to test B and C. A out of it. So the P at B would be, you need to put in these B values in here. The x is 2 going there, the y is 8 going there. So the form is 5 times 2 plus 3 times 3 times 3. Then C now. Here at C. So these values going there again. So the x is 7 coming here. And the y is 3 going there. So it becomes 5 times 7 plus 2 times 3 minus 3 equals. All right, let's go now. That's 10 and 16, that's 26. Minus 3, that's 23, don't it? And this one is what? 35 and 6 make 41. 41 minus 3 is 38, don't it? 38. That one gives it a maximum. See that? Yeah. 38 is correct. It's like 30, yeah, man, 35 plus C is 30. That's correct. Therefore, the maximum value is maximum. P is maximum at C, which is 7, 3. After the maximum value, P max equals 38 is after the maximum. But go to that. Nice and easy. Next question. Function. F and G. First one, G of a half. Plug the half in here, negative a half. It becomes negative half squared. The square negative value becomes positive. Half times half is a quarter. 1/4. But go to that. Next one, I want f of g of negative a half. We already know that g of negative a half is a quarter. But here now we're really working out f of a quarter, but I understand that. But the g of negative a half is a quarter. We just worked out a while ago. We have to work out again. F of a quarter means I want to put the quarter in the f function right there now. Right? So that becomes equal to 3 over 2 times a quarter plus 1 equal. This becomes a half, don't it? That becomes a half. So multiply it by 2 over 2. Multiply by 2 over 2. It becomes a half. So it becomes 1 plus 2. It becomes 6 over 3. 6 over 3 squared. Answer is 6. Plus 30. Let me figure out 2 for that. Huh? Over the 2? All right, that's it. Next question. This is the one. Divided by 1. Next question. F to the minus 1. What is F again? F is this one. F is e over 2x plus 1. Yes, sir. I'm going to inverse it first. We're going to become x equals 3 over 2f to the minus 1 plus 1. I'm trying to make this a subject now. I'm taking it inverse. Make it easy. I'm going to take all of this, multiply it up here, take x and divide it. The first step. I'm going to get 2f to the minus 1 equals 2f to the minus 1 plus 1 equals 3 over x. Balance on that. If we leave this as a subject, I'm going to subtract the 1 and then divide the 2. Subtract 1 first and I get 2f to the minus 1 equals 3 over x minus 1. If you get up this 2, okay, multiply it by a half. Let's do that way. Multiply it by a half. Get rid of this. Multiply the thing by a half. I'm going to get x to the minus 1 equals multiplied by a half. It becomes 3 over 2x divided by a half. It becomes 1 over 2. And then I'm thinking about offering. Okay. That's my answer right here. Now, right, it's a single fraction. I put or. I put up the x to the minus 1 of x equal. Or I don't get this to be a single fraction. Multiply this by x over x. The 3 units will become 12. In that case, it will become 3 minus x over 12. 3 minus x over 12. I want to do that. This. Test I'm done. That's unusual. But must pass 35 by now, you know. But must pass 35. 35 is the pass. Last week was 30, my boy. I don't have to go, you know. Oh, Friday gone. 35. Huh? This paper, no, this week are the 35 week. This week is the 35 week. When Saturday come again, we'll move to the next part now. What's the next part, man? 40? 40 or 45? 40? Okay. Let's go. This question says, a circle and measure. It says, figure below not drawn to scale shows a circle center O, where it is 21, where it is 21. But they must use pi as 22 over 7. What area of the minor sector? Sector is a fraction of a circle. 8 over 360 times pi r squared. This is equal to theta over 360 times pi r squared. Fraction of the area of the whole circle is the area of the sector inside here. That equals to 40 over 360 times 5 is 20 over 7 times the radius squared, 21 squared. What is it to the calculator? So we go. To the calculator. The fraction 40 over 360 and fraction again 22 over 7 over 7 and 154 centimeters squared in the area of the sector. When one you have a triangle, that's a sector triangle, half AB sine C. That's formula we use it. Half AB sine C becomes half R squared sine theta. Comes from the formula half AB sine C. Right? But the A and the B is this radius. Using half AB sine C for the formula for your triangle. The A and the B is R and R. It becomes half R squared sine the angle there is theta. That's how we get that formula for the triangle. Half R squared sine theta. That's the more things you have to get the question then right. Come on. Comes from the other triangle, half A, B, and then C. So this becomes half R squared sine of the angle. It becomes half 21 squared sine of 40 degrees equal. Let's work it out. Half times 21 squared times the sine of 40 degrees. 141.7. 141.7 centimeters squared. Then the one the area shaded. Area shaded here is just the whole sector minus the triangle. So the difference of those two areas. That equals area of sector minus area of the triangle, the sector triangle. It becomes 154 minus 141.7. You're the whole. Subtract 154 here. 154 minus 12.3. 12.2, sorry. 12.2 centimeters square. What's the difference? You give it a mark. 12.3 centimeters square. That's not meters and centimeters square. What about that? Good. Next question. Circle theory. Let's go. Question says, diagram below not drawn straight through the circle center O. If it's a tangent at the circle at A, and angle AOD right here is 72 degrees. The tangent and 4. Tangent and radius right here so it's 90 degrees. Remember that this triangle is isosceles because that's a radius and that's a radius. It's an isosceles triangle. But these two angles are the same. Those two angles are equal. Remember those things. That's what I want. You can give a reason for each step in your answer. Angle ADC. Angle ADC. That angle is subtended by this diameter, as you can see. Angle subtended by a diameter is 90 degrees. 90 degrees. Angle subtended by a diameter. Angle subtended by a diameter is 90 degrees. And that's why it's subtended by a diameter. This is why it's 90 degrees. It is subtended by a diameter. Diameter AC. Diameter AC. That's why it is 90 degrees. Angle subtended by a diameter is 90 degrees. Next one. Angle ACD. Angle ACD. ACD. That angle is half of 73 now. Let's look at it. It's 36. Look. Angle up here the one next. It's subtended by this 4. That angle up here is subtended by that 4. The same chord is subtended 72 degrees at the center. And that center is twice. It's on up here, so it's half of the 72. And the angle at the center is twice. Both angles are subtended by this chord. Center over here. All right, what to do is half of 72. This angle is half at 72 degrees. Reason angle at center is twice angle at circumference. Angle at center is twice angle at circumference. That's what we use. Next angle I want is angle CAD. The CAD. That's right here. AD. That's this angle right here I want. Because we are at this angle here says 36, don't it? It's 36. That is 90, right? Total angle in this triangle is 180. Because it's 90. Therefore, these two are complementary angles, must have to 90. This one is 90 minus 36. Guys, can you see that? See that? You don't see that? Look again. Focus in on this triangle, the right hand triangle, this one. Right, we say 90 degrees. I talked about this triangle. The total angle in that triangle is 180. This is already 90, so these two must have the 90. This is one that the one next. This is one that the one next. This one. This one the one next. This one has to be 90 minus 36. But can you see that? That those two angles up to 90 degrees. That complementary angle. So this angle that the one 90 degrees minus 36 degrees is 4 degrees. That's all. Until the total angle triangle is 1 total. Huh? Same thing. If you have a right angle triangle, okay, if you have a right angle triangle, my youth, this is 90. Them two angles you must always have to 90. Them two them. Complementary angle. If you know one of them is other one is 99. For the right angle triangle. These two angles in a right angle triangle will always have to 90 degrees. Complementary angle. Get me? Yeah. Then you're going to say total angle triangle is 180. The total angle in triangle ABC is 180 degrees. That's what we use. I can go to 90 because we have a 90 there. Then I want angle OEA. Where is that now? Angle OEA. Angle OEA. Let's take these out. OEA. OEA. This one. Watch this now. Let's write angle triangle as well, you know. See here. It's a 93 now. See that? Them two angles here complementary again. 72 and this where them want. This angle has to be 90 minus 72. You have to tell them say the angle is 90. You have to tell them that, don't you? See that? You tell them the angle OAE is 90 degrees. Angle between tangent and radius. Let's write it down. Angle on OAE 90 degrees. OAE 90 degrees. Right angle between tangent and radius. That's why it is 90 degrees. Then this angle that you want now becomes 90 degrees minus 72 degrees. 90 minus 71st is 20, 20 minus 2 is 18, don't it? But total angle in a triangle again. Total angle in triangle. Which triangle we're talking about now? OAE. OAE. Total angle in triangle. OAE is 180 degrees. That's a right angle. One of the angles there was 90. That's how the base color said. Question done. Boom, 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 boom. Boom, 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 boom. One question to do. Start late, start class late. All who never do the paper, you need to go and do it and about the foolishness. I'm going forward, you need to do the paper before I do it. You can learn from your mistakes. Huh? That's the old syllabus. In the past, it used to be 14 questions we used to do, you know. So it will be 14 papers on the paper to choose. It will be 14 papers, the 9 and choose 2. We used to do 11 questions on the exam paper. Then they change it to 11 questions for the all questions. Then they change it to, they change it to 11 questions for all questions. Then they change it to 10 questions. So you are doing now 10 questions, do 10 questions. So these are some of the older syllabus papers. So the same syllabus, same question. Understand? And this syllabus is not too long ago. I think it was 11 questions, maybe up to even 2018, 2019. I don't remember when they changed it to 10, but it's the same syllabus. What I did, that's why the sets now, sets used to be on the 11 questions paper. So they took sets off the 11 questions paper and make it 10 questions. And now you're doing sets only on the multiple choice. So that's why I always say, keep out the sets, keep out the sets. And I took off the sets. You understand? All right, let's go. Question says, points A, B, and C have these coordinates. Bang. M is the midpoint of line segment AB. Remember, midpoint is like an average point, right? It says express each of the following in the form XY, like a column vector. The one OB. So if you have the point B, you know OB have the same value. So this one easy. 4, 2 like that. 4, 2. Don't work needed for this. 4, 2. And we can write OA. OA is going to be same values of that. Negative 2, 8. Okay, right. OC. OC is going to have the same values as this point. 0, 9. Then the one AB. O times the last minus O times the first. So it becomes OB minus OA. B is the last, A is the first. Well, you know the portion vector, that's why you get a displacement vector. This is what we call a displacement vector between 2 points. The portion vector is the displacement from the origin to the point, carries the same values as the coordinate. So then OB minus OA. OB is this one, 4, 2. Minus OA is this one, negative 2, 8. Write this out. 4 minus 1 is a plus, that gives us 6. 2 minus 8 is negative 6. That's the vector AB. Then M is the midpoint of AB, don't it? M is the midpoint of AB. So like an average point. Just like when you average the coordinates, averaging the points. If you want it, you could find the coordinate of the midpoint between these 2 points first, and then put the O and put right as get the coordinates of the midpoint. I take the midpoint between those two the normal way, and then OM would just have the same value. So let's average the portion vectors, guys, for OM. So OM becomes half of OA plus OB. Averaging the portion vectors to get the midpoint. So it becomes half of. You're adding the OA and the OB now. So you're adding the values on the A and the B. So if you adding these values, this and this. So minus 2 and 4. Minus 2 and 4. You're averaging these values. That's 8 and 2. 8 and 2. 8 and 2. 8 and 2. You don't think you have a lot of space to work for. So this is 2. Half of 2 is 2. Let me shift this over. They don't give a lot of space here, man. Make it smaller. There's no way to shift it. They don't give a lot of space to work. You have to be efficient with what you're doing. Good. Let's zoom up now. This is 2. Half of 2 is 1. This is 10. Half of 10 is 5. That is it. The portion vector of M is 1, 5. So want the coordinates of M, it will be 1, 5 like this. M is the point 1, 5 like that. So I'm saying we could have calculated the midpoint normal way by averaging these two values, average them, and then average these two values to get the midpoint. We get the midpoint as 1, 5. So the midpoint is 1, 5, then OM will have the same values. 1, 5. All right, so I've done it that way as well. Anyway, next part says, Use a vector method to show that AC and OB are parallel. If they are parallel, one is a multiple of the next. I'm able to show that. So we need to work out the vector AC first. Now we do have it here. AC is OC minus OA. OC is 0, 9. So 0, 9, let's look at it. Yeah, 0, 9. And OA is negative 2, 8. Minus negative 2, 8. The zero to minus plus the zero to 2, 1. What is 8? OB again. OB is the vector. What is OB again? OB is 4, 2. 4, 2. Can you see that this big one is 2 times this small one? Can you see that? Obvious, don't it? The big one, you can say, therefore, the big one, OB, is 2 times the small one, AC, don't it? This and those values, right? This means that they are parallel. By you getting one vector equal a multiple of the next, it means that they are parallel. So you can say, therefore, OB is parallel to AC. That's what this means. When you establish one vector as a multiple of the next, it means that the lines or the vectors are parallel. Hey, you start running to the class with this outburst all the time. I get tired of that, man. I do it over and over again and I'm not saying anything. The past is speed now, make stop saying nothing. I'm going to say something, I'll ask them to leave and don't come back. That's what it's going to be. That was the same people them over and over again all the time. I can't take the foolish. All right. Let's go. Next question says, the matrix M is given as this. And I want us to determine the value of P for it is singular. Remember, if it is singular, it has no inverse. It has no inverse. So it should have told you that it has no inverse. It has no inverse, so the determinant of the matrix is equal to 0. Now, when the determinant is 0, this product becomes equal to that product. Good? When the determinant is 0, two diagonal products are the same. Because to get the determinant, you have to subtract the diagonal products. So when the determinant is 0, you need that the two diagonals have the same value. The diagonal product is the same value. So we can say that this product, which is 2p times 1, is equal to this product, which is 4 times minus 3. But understand that? Two diagonal products equal when the determinant is 0. This is negative 12 divided by this 2, you get p equal negative 6. So, better go to that. Nice and easy. Next question. Gives us these two matrices, A and B. Wants us to work out 2A plus B. So it's 2 times this one plus this one. Easy. Equals. 2 times this one means that you multiply all the values in here by 2. So this value becomes 2. This value becomes 4. This value becomes negative 8. This value becomes 6. This is your 2A. Plus B means that this one has A. 5 minus 1, 0, 3. Then you add the like terms to get the answer. 2 and 5 is 7. 0 minus 1 is 3. Minus 8 and 0 is negative 8. 6 and 3 is 9. That is your answer right there. Very good? Nice and easy. Next one was the inverse of B. What is B again? B is, let's just write it to have it on the screen. 5 minus 1, 0, 3. Inverse is 1 over the determinant multiplied by the adjoint. So B to the minus 1 equals 1 over the determinant. The determinant is this product minus this product. Write it out. 1 over the determinant times the adjoint. Write it out. B to the minus 1 equals 1 over the determinant of B times the adjoint of B. All right, so B to the minus 1 equals 1 over the determinant now. This product, which is 15, minus this product, which is 0. Multiply by the adjoint. Interchange these two values on the first diagonal. Interchange them. 3 goes here, 5 goes here. Leave those two on the second diagonal where they are. Just change the sign. Change this one to change this -1 to a 1. 0 to have no sign, so it stays as 0. So each of these divided by 15. Ready? Equals 3 over 15. Right. 3 over 15. 1 over 15. 0 over 15. 5 over 15. Equals 3 over 15 is 1/5. 1 over 15 is 1 over 15. 0 over 15 is 0. 5 over 15 is 1/3. That's his answer. Gotta go to that. Beautiful. Next part says, give us this now. Note that this is the matrix B right here. Matrix is actually B. I want us to calculate the value of X and Y. It means that the inverse of B is coming in front of this 9, 3, don't it? You leave X, Y as a subject, right? Good. Must know that by now. So the XY is going to be equal to B to the -1 times 9, 3. And B to the -1 is this matrix. I like to leave the fraction outside for last. I work with the 1 over 15 times these values might be to the -1. Instead of this one with all those fractions. You get me? I want to use this one as 1 over 15 times this from a B to the -1. I'm going to put 1 over 15 times, what is it again? 3105. 3105. 3105. Multiply by this 93 now. 93. So multiply use the fraction out here for use the fraction for last. 1 over 15. 1 over 15. Into. What you get here? First value is first row 1 column. To get it to multiply this first row by this 1 column. First element times first element, second element times second element. First element to be root and the first element in the column. Second element to be root by the second element in the column. First element times first element, second element times second element. 3 times 9, that's 27. 1 times 3 is 3. This value here is, for example, second row, 1 column. Second row with the 1 column. First element times first element. Second element times second element. 0 times 9, 5 times 3. 0 times 9, 5 times 3. So 0 times 9 is 0. 5 times 3 is 15. So nice friendly value. You can basically write the final answer now. Now this is really 30 divided by 15 is 2, don't it? If you really 15 divided by 15 is 1, right? And xy equals that. Let me state the value explicitly. So x equals 2, y equals 1. These are your answers. Very good. End of this test. And that is that. Is that? All right. Everybody must get over 30 pounds. Most. Good. All right. 35 next week. Progress before perfection. No, 35 I mean, everybody must get to over 35 on this. So this week is 35 week. So remember, I doing a mock exam Wednesday. I did a mock exam Thursday. Remember, we're going to the other paper tomorrow. So you guys join online. Tomorrow evening, 5 o'clock, join online. We're going to the next paper. All right. Bye, everybody. See you.